Hello developers, let's start developing. Today we're taking on task 8 and I have some bad news, it's geometry. Fortunately, the input is relatively straightforward. We have three numbers and those three numbers are basically the coordinates of a junction box and we need to connect some junction boxes to other junction boxes. And that's all that we will need to do. So we need to compare them by the straight line distance, which is the Euclidean, which is this thing in 3 dimensions. So we're gonna need to calculate the distance between each and every pair of them. So yeah, let's do it. So we're gonna process each line, that lines dot map for each line dot. Actually, we're gonna do it this way. We're gonna have a type called point that's gonna have literally x and y and z. So we're gonna line dot split on a comma. The good thing is that all of these, not these, all of these points are positive. So we're only working in one octant, so to say, the one where everything is positive. I don't think that we have a minus. Over here we don't, so yeah, we can do everything positively, which kind of means that once we split it, we can say, well, this is gonna be split into x, y, z, and return that thing. We're gonna make a number out of that, and that is gonna be a point. So this is points because that's an array of points. So instead of an array of strings, we're just gonna have array of points. Seems okay, only we need to actually return the points. Let's see if we got the correct thingy. Where are you? Not you. You. npm run, start debug, task 8, so that we get the data that we put in. This is the small set of data. We have xyz, xyz. We have those many and that. And there is a update to npm. Of course there is. So now for each set of points, we have them in an array. We need to calculate the distance. Let's have it, yeah, we don't need that. We're gonna need to have some kind of a nested for loop. Index, and this is gonna be not index but findex, index of the first one, and that's up to the points, and the first element is actually the input.findex, and yeah, we're gonna need to have a second thing, and we're gonna need to calculate the distances. So the distance is the root of the sum of the squares of the differences. Yeah, we have that distance, and the distance between point index 1 and index 2 is that many. So this will be an array of other objects, so we're gonna have another type here, a distance. So I will just, to avoid having the points, actually, why not? We don't really need the indexes, we can put the whole points, it's just 3 numbers. So we have that thing, so the distances will be a distance array. Yep, we just push that inside the distances. And we have the distances. And now we're gonna need to distances dot sort by the distance. D of distances, just print, no, printf, no, just console log the, good enough. And we need to have a return here, so that we can get the we need to see the distances themselves. So we have that many points and these many distances. It rises with the square of the numbers. So we kinda only care about the top 10 in this case. The 10 shortest connections, there are 11 circuits. So when we have the 10 shortest connections, we can stop. So for now, let's just say distances dot slice, well, from 0 to 10. That will give us the 10 shortest. And let's see if we have the actual values, the correct values. So this thing says that the shortest distance is between 906 and the touch junction boxes which are closest together and is that one and that one. So yeah, our calculation is that correct. So that one and this one. And seems like it's, and the third one, that's the third one, that's the fourth one. It's great. So now we need to do some kind of a graphing on them. So the task is relatively complicatedly worded, but basically we're gonna draw these lines, so to say, and we need to see how many distinct circuits we get. And a circuit is basically, if 5 junction boxes are tied together, doesn't matter in which way, they count as the single circuit. So we start with 0 connections, we start with 20 different separate, so to say, circuits. So, and the first connection lowers that number to 19, and the other one, actually the top 10 lowers them down to 11 circuits. One circuit with 5 junction boxes, one circuit with 4, and two circuits with 2. And the result is, yeah, multiplying together the sizes of the 3 largest circuits. So we need to find the circuits. There was an algorithm that I was actually doing this, but the bad thing is that I don't know that algorithm. On the other hand, we calculated a lot of this. Let's see just how big the big input is. 1000, so we're gonna calculate around 500,000 of different distances in order to get the top thousands. So anyway, these are the relevant the junctions that we make. So we need to actually connect these junctions into the graph and see how many are connected. Maybe we would like, yeah, so when we're finished with this, actually we don't really care about the distances at all, which means that in our distances I will rename this into a key distance, since this will now be a string. Because I will key the point. Yeah, we're going the other way around now. So from a point we're generating the string. So over here we're not gonna put in the first and the second, the points themselves. We're just gonna, yeah. So once we get the junctions, yeah, now we can log them. Something like this. Yeah, this sounds similar. And now what we can do, we can make a sort of, so everybody is in a circuit of their own. So we have everybody that's not here will be in a circuit of their own. So that's not really relevant because, yeah, we're gonna get some circuits. So what we want to do now is to have some here it's, and let's have that as an array. So now we're gonna need to put for each of the elements so this is gonna be a jagged array. So this is gonna be an array of arrays for each, yeah, junction of junctions. We can take the first one, yeah, and we can actually immediately do this because we only care about the first and the second one. We don't really care about the distance. We use the distance to slice it and dice it. So once that is done, we have our first and the second. And now for each of the circuits, we're gonna loop through this. Yeah, this is gonna be a array of arrays of strings, where we have the keys, because now we're only working with the keys. So take the now we will what we will do, take the first one, see if it's in any of the circuits. It needs to be in exactly one of the circuits. So if it's already in one of those circuits, then we will optionally add the, actually this is, and let's not have it as array of strings, we can have a set of strings. Yeah, this will be an array of sets of strings. Yeah, you don't often see this kind of types in TypeScript, but they will be useful. So yeah, if the circuit has the first and the circuit has the second, we don't really care about that. Actually, let's write it a bit. is the first in any circuit. Yeah, so find the circuit for the first, find the circuit for the second. And now we have four different options. If both are in a circuit and they are not in the same circuit, if they're in the same circuit, we're done. We don't need to do anything. So if they're in different circuits, that means that we need to merge those. So yeah, creating a new set. We are removing the second circuit from the circuits, and the first one we are setting to be the first circuit. So we're taking everything that's in the second circuit and merging it to the first one. Otherwise, if the first point is in a circuit and the second is not, then that means the second joins the first circuit. Otherwise, if the second is in a circuit and the first one is not, that means the first joins the second circuit. And if none of them are in a circuit, we need to create a new circuit, which is just those 2 points. Yep, that's all there is. Once you explain it, it kind of looks obvious that these are the four options, but it needs a bit of management, so to say. So yeah, we're gonna loop through all of that, and now, yeah, let's just write out the circuits. So we found one circuit of length 4, two circuits of length 2 and of 3, and two circuits of length 2. This is not the correct answer, but it kinda looks quite okay. Let's just finish up. So sort the circuits by size. Yeah, by the size of the set. Take the first three. Hmm. We deconstruct them in that, and we need to return basically, actually, let's call them top 1, top 2, and top 3, and then we yeah, if there is only 2, we will multiply by 1, so doesn't really matter. This is a bit longer. I would have just multiplied them because we know that there's gonna be 3. If we don't find 3, we have bigger problems. But yeah, this is the technically correct way to do these things. So if we run them, we're gonna get the wrong answer. We're gonna get 24 instead of 40. And let's analyze what happens. So we have our distances, and I left the debug prints intentionally because I felt that we're gonna have some problems. So these are the closest junctions. So do we have any duplicates in the first? In the first point? Let's just say yeah. We sorted on the X. We're gonna go back on this. Why am I doing this? Because I will actually now refer to the points with their x-coordinate, because their x-coordinate is sufficiently different. In order not to say 162, 817, 815, this is 162. So we have, let's get into our trusty Excel and see what we have. We have these paste special. I want to paste text only. So we have 162 to 425 and then 162 to 431. 162 exists, 431 doesn't exist, which means 431 should get added here. 805, 906, those are two different. 425 to 431, nothing happens. I think nothing happens. Let's go through the code. This is when this is true and this is false. So yeah, nothing happens. 425, so 462, 862, 984. 52, 117. Yeah, that's a new one. 52, 117. And let's write up the operation. What we do? So here we create a new. Here we add to a existing one. Here we create a new. Here we do nothing. Here we create a new, and here we create a new. Here we have 819, that's the first time that is mentioned, and 941 again, so we are creating a new one. 941, so we're creating a new one. 739, first mention, and 906, second mention. So we are adding 739 to this. Oh no, this is not that, this is add 346, first mention 425, already existing, so we're gonna add 346 here. And we have 906, 984. Oh, we have these two, which means the join should happen. Which means that this thing should go over here. And that didn't happen in our code. So that's how we get a 4 and a 3. Yeah, we can see we have the 162, 425, 431, 346, and we have it in the exact way. But we also have this one. We did manage to delete the 862, 984, but we forgot to add it here. That's where the bug is. So we are setting the first circuit to be a combination of the first and the second. Then we are removing the second one, and then, oh, yep, this is the fuck up. This is, we already changed the first circuit, so now when we're looking for the index of the first circuit, it says, I don't have that. So I will say this is the joint circuit and do it like this. Yeah, the nice thing when code gets generated is that you have code that's generated. The bad thing is that you have code that's not tested. And this is a JavaScript intricacy that kind of messed us up. Now we have, yeah, everything is as it should be, and the result is 40. Let's just see how this looks if we run it properly. Yeah, just runs. So now we have a bit of an issue that I hate doing in tasks, is that the biggest input doesn't use the same exact logic as this one, because we don't have the top 10. But we have the top 1000. So let me just find where the slice is. Yeah, we're gonna use that value. Yeah, I don't want that. I abhor the uh, for each method, so I will always change it with a for of loop. That's a looping construct. Closest junctions, we have everything. We have circuits found. Yeah, looks okay. Actually, we can do it this way. It's a bit better. First we sort them and then we print them. The problem is that for the big input we need to take care of the 1000 top junctions. So, which means that we need to change it here and also change it here. Basically, our input is in two parts because this is also a part of the input. It is what it is. Let's run it in a debug way. We will get a lot of data. You saw that it stalled for a second. It almost took a full second to run. We found 136 circuits, so it's more than 3. And the top circuits are quite biggish. We might have written the length as well. That would have been nice. Circuit of size so it took an almost a full second to run this. So we have 88 and 43 and 37, and I guess the product of those three numbers is this much. Let's see if that is the actual correct code. Yep, we got the right answer. So I have a feeling that the second part will do something with the minimum or maximum array or something like that. We're gonna need to optimize some metric, and let's see 3. Yeah, they definitely don't have enough extension cables. You'll need to keep connection junction boxes together until they're all in one large circuit. Continuing the above example, the first connection that causes all of the junction boxes to form a single circuit is between the junction boxes at that many. How far those junction boxes are from the wall so they can pick the right extension cables. Uh-huh. Yeah. Seems quite easy to do actually. We already have the distances, we already have everything. So yeah, I kinda did a lot of code. Now I will refactor this a bit. So, yeah, oops, sorry. Didn't mean to ask nobody anything. So I want to refactor this into a function in module scope. We need to call this gene get distance. Where did it put it? Exactly why I didn't want it, it put it at the end. I would much prefer to have it somewhere around here. So we don't even need this. Yeah, we can actually rename this still to distance. So get distances will, for a given set of junction boxes points, will generate the distances. So now we're generating the distances, getting some of them, and then running through those junctions and creating circuits. So now we need to run through those junctions until we get a single circuit. Actually, now we can do something similar. The problem is that now when we start processing this, we kinda ignore all the circuits that have one element only. Now I will actually do it the other way around. So what did I do? Yeah, let's take the first part 1, copy and paste it over in part 2. And let's see what we have. So we have this, this doesn't matter at all right now. Junctions are basically distances. We don't really care about that. We have our circuits, and now we're gonna go through all of our inputs and generate a circuit for that. Because I cannot say right now, run until you get one single circuit, because the first time I go through this loop, it will generate the first one. And it will say, oh, I'm done. What we can do, we maybe wanna start it up with here's 10, but it's kinda tricky and it's kinda hacky. So I will waste a bit of memory and say, well, for this structure, we're gonna take the input and basically map the input into each point. It will generate it into a key, and from each key we will generate a new set, and that's what we have. So for each of those distances, and the distances that we get are sorted, if I see correctly, and that is how we want them. So for each of them, so now even the first time we go around, we're gonna get we're not gonna get these cases right now. So each time there will be a first circuit for the first one, and there will be a second circuit for the second one. And so we just need to check this. If there is a thingy, merge them. So this is not gonna happen, this is not gonna happen, this is not gonna happen. That's all there is. There will be a first and a second circuit. We are sure of that. Now it says, but I don't know if there will be. Yeah, buddy, I know that there will be, because I just created it 2 lines up. So now we're not gonna only do that, but we're gonna do something more. We're gonna say how many circuits are there now, because each time this executes, we're lowering the number of circuits. Let's say that we have const current size is circuits dot length, and here I will say if that the length is less than the current size, which means we went out. Let's just console log, not that, dropped to that many circuits. We don't need to break, we just can continue. Yeah, this is a debug because I kind of just want to see this happening. We're gonna start with 1000 circuits and we're gonna go down, down, down until we get circuit length of 1. When we do get a circuit length of 1, then we actually need to see which junction, which extension cord, so to say, did that. And that's the connection between first and second. So console log, we connected first and second to make a single circuit and break, and then we kind of don't need to do anything. Let's just take a look at how this will work with the small input. We're starting with 20 circuits, dropping to 19, 18, 17, and you can see that it's going to 2. I kind of need to remove some of that. So we connected 216 and 117 to make a single circuit. When we do that, we actually have our solution, which is the multiplication of their x coordinates. So we can add this and then basically say no, that, not that. We can just return first of x. Oh, you know what we do need to do right now? We need first is actually the key, and from that key we need to make it into a number. So split on a space, we need to say well how much fx is, and take the first element. Second x is, yep, we don't need the difference, we don't need anything, we just need fx times sx. And over here we can have throw new error that we couldn't connect our circuit, so we're not going to return. This is the return statement that occurs if and when we get to that. And as I mentioned, we want strict strictly going down, so we'll get a little bit less messages. I don't know what I messed up. Oh, I know what I messed up. I messed up that we didn't check the current size is equal to the length, because this is a constant. So now we will get less output, but we can see how we're dropping it. Result part 2 is 25,272. 25,272. Now, yeah, note that we might get the wrong answer now for the first part. We got 20 instead of 40 because the things remain to be at 1,000. I will change it back to 10 and no, let's leave it at 1,000. Let's just put it with the big input and let's see what it goes. So we started with 1,000 circuits and slowly drilled down to 1, and those are the two it connected, and this is their x's multiplied. Let's see if this is the correct one. Yes, and I'm quite happy that we managed to do the geometry together. There wasn't too many geometry, there was more like graph management and everything like that, but it was kind of fun, at least for me. Hope this helps you in your solutions and hope you had an interesting time. And don't forget to like, subscribe, comment, and everything else. Keep developing.